Hey, welcome back to your favorite technical mathematics class. We're going to talk about area today. Find the area of some geometric shapes. So for a rectangle, you have the length times the width will give you the rectangle of a triangle. Like for instance, if this is, I don't know, 5 and this is 3, then you have 15, 5 times 3, 15 of these square little units. That's what it's saying. 15 of those, 5 times 3, there's 15 total of those. So it's like how much grass do you have is how much area. You know, if you have a square, on the other hand, it would be length times width, 3 times 3, or in other words, 9 square units. Total, make that up. For a parallelogram, you have the base times the height. Now the height, you got to be careful here. It's got to make a 90 degree. So you have to take the altitude there. That's your height for a parallelogram. So for instance, if you have a parallelogram whose altitude is 20 inches, so that's the height right there, the 20 inches right there, and the base is 18. So you got base times height, base is 18, height is 20. This ends up being 360. And this is, I should say, this is inches. This one's inches, so inches times inches is square inches. So you got 360 square inches for that parallelogram. Well, if you take a rectangle, base times height, or length times width, and you cut it in half, you got a triangle. So 1/2 base times height is for a triangle. Okay, so for a triangle, 1/2 the base times that height right there. So find the area of a triangle whose altitude is 22 inches. So they're saying that's height is 22 inches and the base is 9 inches. So you just plug it in. 1/2 base times height. 1/2 the base is 9 times the height is 22. And you multiply that, and this is inches, this one's inches. So it looks like that ends up being 99 square inches. Area of that triangle there. Well, Heron's area formula is a nice formula to find the area of a triangle when you only have all the side lengths. Okay, so if they give you this area here is 15 in the example, the B side length is 8, the C side length is 9, what you do first is you find what's called the semi-perimeter number 1, and then you can plug it into this area formula, number 2, and you'll have the area without even needing the height or the altitude of it. You just have the 3 side lengths. Okay, so let's do that for this 15, 8, and 9 side length formula. So number 1, let's find the semi-perimeter, it's called. That's where you add up all the side lengths and divide it by 2. So we got 15 plus 8 plus 9. We divide all that by 2. So what's that? 32 over 2. So we got 16 for our semi-perimeter here. And then number 2, now we can find the area according to Heron's area formula. You take the S times S minus the A times S minus the B times S minus C. And you take the square root of all that. So we got 16 is our semi-perimeter, and then 16 minus the side length A, which is 15, and then 16 is our S minus our side length B, which is 8, and then 16 minus our side length C, which is 9. So we got 16 times 1 times 8, 16 minus 8, and then 16 minus 9 is 7. So we got 16 times 1 times 8 times 7. I'm not sure what that is. Punch that in. So that's 896. And then we're going to take the square root of that 896. And it looks like we got 29.933. 29.933, that's a 0.933. And this is, again, square inches or square whatever your units are because it's an area. So that's Heron's area formula. Now the area of a trapezoid, if you think about the trapezoid being the yellow triangle plus the pink triangle, So that's the yellow triangle part. That's the pink triangle part. If you add those up and factor out the 1/2 h, you end up with the equation for the area of a trapezoid. Area is 1/2 the h, so the altitude right there, that's our h, times the summation of the base A on the one triangle and the base B on the other triangle. And the A and the B are always the parallel sides. Okay, so for example, oops, let me do an example. Let's say we've got, I don't know, let's say we've got a height of 3, and we got 7, 6, 9, and 27, we'll say. Okay, so the area is 1/2 h times A plus B. So you got 1/2 the height. And then again, the A and the B side, you've got the bases that are parallel. So that's the 27 and the 9 there. So you got 1/2 times 3 times, what's that, 36. So let's see, that's 18, half of 36, 18 times 3 is 54. So it looks like you got 54. And again, this is square, whatever your units are. That's the area of a trapezoid. Okay, we could do the area of a circle by going pi times the radius squared. So if your radius, you know, let's say you have a radius that's 3, you'd say, well, pi is 3.14 times the 3, which is squared. So you make sure you do the 3 squared first. So 3.14 times 9, and you get 28.26. Now this example is a little different because it says find the area of a circle with a circumference of 5. Well, you got, for the area you need the radius. So the first thing you got to do here, number one, is you got to use the circumference. Remember, circumference is 2 times pi times r. Use the fact that the circumference is 5 feet to find the radius. So divide by 6.28 both sides here. So our radius looks like this ends up being 0.796. And now that we have the radius of the circle, right? Now that we know that this radius is 0.796. Oops. Radius is 0.796. Now we can plug it into pi r squared to find the area of the circle. So 3.14 is our pi. Our radius is 0.796 squared. And again, if the instructions in my math lab tell you to use 3.14 for pi, go ahead and do it. If it doesn't, you can use the pi button for that. Okay, so make sure you do 0.796 squared first, and then times that 3.14, and you get the, looks like this ends up being about 1.99, or I'll round that to 1.99. Okay, well, thanks for listening. We'll see you soon.